In this video, we're going to use properties of similar figures to determine if two figures are similar. So first, let's go over what it means for two polygons to be similar. So I have a sketch of two similar polygons, and notice this symbol in between them. That symbol means is similar to. So I say this triangle is similar to this other triangle here. Now, when I say two polygons are similar, I mean that two things happen. That corresponding angles are congruent. So I would say one angle is congruent to another. And corresponding sides are proportional. And we use the little ratio symbol for proportional. Now, what I mean by corresponding is matching. So this angle with one curve matches with the angle with one curve here. The angle with two curves matches with this angle with two curves in a bigger triangle. The side that matches the one with one and two curves is going to be the one on the bigger triangle that has the angle of one and two curves. So those two sides would be proportional in those two triangles. All right, so use the figures below to answer the questions that follow. So what we're trying to say is, what would match with what? If triangle ABC is similar to triangle XYZ, then angle A is going to be congruent to angle X. So notice triangle ABC, XYZ. So side BC is here. It would match with side YZ. Angle B is going to be corresponding with Y. And so since we know they're similar figures, we know angle B is congruent to angle Y. Side AB is proportional to side XY. Angle C is going to be congruent to angle Z. So angle C corresponds to angle Z in the two triangles. And side CA is going to be proportional to side ZX. So we're just matching up the corresponding pieces. Okay, go ahead and pause here and try this example. If the quadrilaterals below are similar, then what must be true? So right here, I've written what's called a similarity statement, so notice that here. Quadrilateral ABCD is similar to quadrilateral EFGH. Notice we already have markings on each quadrilateral to indicate which angles are congruent. So if we know those quadrilaterals are similar, we know which angles are congruent and which sides are proportional. You would have to write those statements for each set. So angle A would be congruent to angle E. Angle B would be congruent to angle F. Angle C would be congruent to angle G. And angle D would be congruent to angle H. The sides that are proportional, AB matches with EF. Notice that one has one curve and two curves here. So we're matching up the angles, and it's the side that's included or between those two angles. So AB is proportional to EF. BC is proportional to FG. CD is proportional to GH. And DA is proportional to HE. Okay? You try this example for the triangles LMN and RST. Notice you will have to draw that picture first. Now, I used a term a little bit ago. I said the side is included between the two angles. What I mean by that is it's the side that is between two angles. Or if I say an angle is included, I mean it's the one that's between two sides. So which angle is included? between AB and BC? Well, here's AB and BC. So it's the shared letter between them, or the shared angle between those sides. So angle B is between sides AB and BC. Which side is included between angle E and angle D? Angle E is here, angle D is here. So side ED is the segment that's included between those angles. Which angle is included between AE and AB? AE, AB are the two sides. The angle that's between those two sides is angle A. All right, here's an example for you to try for triangle MAC. Now we're going to determine if two triangles are similar. So we have to check for two things. We have to check that corresponding angles are congruent. So looking at these two triangles, we see both triangles have a right angle. So we know one set of corresponding angles are congruent. But notice that there's one angle missing in each one of those. Recall from 8th grade or 7th grade geometry that the sum of the angles in a triangle are 180 degrees. So if I were to add up the ones I have and then subtract that from 180, I could find that missing angle. So 90 plus 37, subtract that from 180, and we get 53 degrees. On this triangle, we have 53 plus 90, subtract that from 180, and we get 37. So notice that 37 degrees and 37 degrees match and are congruent. 53 and 53 are corresponding and are congruent. So far we know that all of our corresponding angles are congruent. The second thing we have to check for is if corresponding sides are proportional. So I have to set up ratios to be able to represent those proportions to check and see if they're proportional. So I would set up a ratio that says 9 over 6, 18 over 12, and 3 over 2. The reason I set up these ratios this way is because the shortest side on this triangle is always going to match with the shortest side on the other triangle. Notice it's also the one that's included between the 90 and 53 degree angle. The one included between the 90 and 53 degree angle will match with it. So 3 to 2 is a ratio that we would use. The longest side in this triangle is 18, will match with the longest side in the other triangle, 12. 18 divided by 12 will reduce to 3 halves. So far we know those sets of sides are proportional, but you have to check all of the sets. So we set up that last ratio of 9 over 6. 9 over 6 also reduces to 3 halves. And so we know the figures are proportional, so therefore the figures are similar. Once we know both of these things are true, you have to check for both. Now notice in these two triangles, there was something that we could multiply by to get each of those new numbers. That's called a scale factor. So in these quadrilaterals right here, if those two are similar, which we have that symbol between them, so quad ABCD is similar to quadrilateral EFGH, what is the scale factor? All you have to do is set up a ratio and then reduce it. So from ABCD to EFGH, I see that my scale factor is 2. So 10 to 5. So I would have had to multiply this 5 by 2 to get 10. Show the ratio of the perimeters is the same as the scale factor. Well, we have our two figures here. We could find the perimeter of ABCD by adding up all the sides, 10 plus 5 plus 6 plus 8. We could also do the same thing with 2.5, 3, 4, and 5 for quadrilateral EFGH. Once we do that, we see we have a perimeter of 29 for ABCD and a perimeter of 14.5 for EFGH. Well, if we set that up in a ratio, 29 to 14.5 is a ratio of 2 to 1, or 2. Now, what is the scale factor of quadrilateral EFGH to quadrilateral ABCD? Well, now we're just going in the other direction. So now I'm going to set up a ratio of 5 over 10. Well, notice now it's just 1/2. 5 over 10 is 1/2. What do you notice about the scale factors from example 6 and example 8? Well, this was example 6. This was example 8. What do you notice about 2 and 1/2? Notice that they are reciprocals. They're just the flips of one another. So all you have to do is flip it over to find the scale factor going the other way. In this example, we have two polygons that we're going to find the scale factor for, and then the perimeter of each polygon. We know the scale factor of the perimeters should be the same as the scale factor for the sides. So we first need to find the scale factor for the sides. So in order to do that, I need to match up two pieces to form that ratio for the scale factor. Notice that in the names we have A and P that are the first letter. That means those points or those vertices are going to match or be corresponding. So A is corresponding to P, B is corresponding to Q, and so on and so forth. So I look and see AB is going to match with PQ, but I don't have a measurement for PQ. So I have to find another set. I do have CD, and in the names, C to D is going to match with R to S. I do have R to S and CD, so I can use that to set up a ratio. So I'm going to set up the ratio as 4/3 because I'm going from the bigger polygon to the smaller polygon. So my ratio or my scale factor is 4/3. Now I also know some pieces are congruent based on those dashes that I see on the picture. I know AB is going to be congruent to BC, so BC has a measure of 8. I also know that AE and CD are congruent, so both of those have a measure of 4. So I can find the perimeter of ABCDE by just adding up those sides, and I get a perimeter of 30. Now what I can do is I can use that scale factor to be able to solve for the perimeter of PQRST. I know that 4:3, the ratio of the sides, is also the scale factor for the perimeter of ABCDE to the perimeter of PQRST. Well, 4/3 is now going to be equal to 30 because 4 was on ABCDE and 30 was the perimeter of ABCDE. We want to make sure that we set it up in the right way. 3 is on PQRST, and X represents the perimeter that we're trying to find. So now cross multiply 3 times 30 and 4 times X. 3 times 30 is 90. 90 equals 4X. Divide by 4 on both sides, and we get 22.5. If we were to put 30 divided by 22.5 in our calculators, we would get a ratio of 4:3. Right, in this diagram, we know that ACDF is similar to VWYZ. So A is going to match with V, C is going to match with W, D is going to match with Y, and F is going to match with Z. So what I want to do is I want to be able to solve for X and Y. Because I know these are similar figures, I know I can use proportions. So I can set up a proportion to match up pieces. I know that CD is going to match with WY, and DF is going to match with YZ. So set up that proportion and then solve for the missing part. And here we would see that X is 15. We're going to do the same thing for Y. I know that 12 is going to match with 3Y minus 1. That side AF is proportional to VZ. And I just use two other sides that I know will match up, and solve that resulting proportion.